In this video, we'll use the normal model in a different way. This time we're going to start with a percentage and we want to find a cutoff for that percentage. In this example where we have that the average number of faces an adult can remember is 150 with a standard deviation of 30 and a normal model, we want to find the 5th percentile. So that's just another way of saying the lowest 5% of adults would be able to remember how many faces. We need to know how many faces. That is our question. So it's not finding a probability like the last few examples. Now we need to know the faces that cut off that lower 5%. I'm going to draw a picture of this lower 5% so we get a visual. There's the mean of 150, and this is our lower 5%. So the question is, where is that? Is it 100 faces? Is it 95 faces? I don't know, but I just know that that area is 0.05, standing for the 5%. So we are going to use this z-score formula again. X minus mu divided by sigma. But this time we have different information. We do not know what x is. That's what we're trying to figure out. X is something, it's unknown. I still know the mean to be 150, and the standard deviation is still 30, but, well, what is z? That's another piece that we don't know, but we get it by knowing the percent. So if I look at 5%, I'm going to look at this on a normal model, standard normal. Mean of 0, sigma is 1. Here is that 0.05. Oops, 0.05. So on a standard normal model, what's a cutoff for 0.05 or 5%? I'm going to go to my normal table here. Again, it's finding area to the left. I'm going to look in the middle of the table. So this is different than before. Before I started with z-scores and then I figured out what my percent was. Now I'm going to use the table backwards. Where is 0.05? And then let's work backwards to get to the z-value. Well, I've highlighted a couple numbers already. I've searched through the table looking for 0.05. I didn't find exactly 0.05. This happens. What I do have is 0.0495 and 0505. That's about the closest thing to 0.05 that I can get. If I backtrack to the side, I'm on the row that is negative 1.6. The columns are 0.05 and 0.04. So somewhere between negative 1.64 and negative 1.65, I will get 0.05 area. Well, you can pick either one of those for your z-value. Working by hand, it's known there's going to be some error. It's kind of halfway in the middle, so you can just pick one, or you can always undershoot, always overshoot. But as long as you're in the ballpark, this is fine. I'm going to use negative 1.6. Let's go up. Negative 1.64. So I need to find negative 1.64 from our table to fill in this equation. Another way that you might find this equation is x equals z times sigma plus mu. That's just doing a little bit of algebra solving for x. So x is equal to z, negative 1.64, times sigma, that's 30, and then add 150. If you want to, you can do the algebra, prove to yourself that these two equations are equivalent. They've just been solved for different variables. All right, go to the calculator now. Negative 1.64 times 30 plus 150. Typed it in just like I wrote it, and I get 100.8. So what I just found, I'm going to fill this in. Negative 1.64 was the z-value that I used. Equivalent x is equal to 100.8. So the lowest 5% of adults can remember about 101-ish faces or fewer. Now, what does this look like on StatCrunch? I had to do a little bit algebra and solve. StatCrunch will make this go a little bit faster. All right, in StatCrunch, I'm going to open up the calculator, the normal, and I'm going to use these fill-in boxes a little bit differently. I know that my mean is 150, and the standard deviation is 30, but this time I do not know what my x value is. I'm going to leave this box here on the bottom row blank. What I do know is that the probability of being below, so less than or equal to, below that whatever number, it's going to be 5%. So if I tell StatCrunch, give me the 5th percentile, push compute, let's put in those nice tick marks there, it comes up with x less than or equal to 100.65439. So anything less than 100.6 or 0.7 faces is in this lower 5% of area. So this is pretty close to what we computed by hand. It's 100.8 versus 100.65. StatCrunch is more precise. We didn't have to round. Remember that. Was it negative 1.64? Was it negative 1.65? We didn't have to do any guesswork. It used the exact value, and that's why we get a little bit different answer. So the 5th percentile, that cutoff for the lower 5%, is at 100.7 faces or 100.8 faces.